All right, so we're just going to continue with SQL today. Remember that your design document is due today by midnight, and next week is the last week before spring break. You've got your assignment 3 due on that Friday. So some observations from what we were doing last time. Comments usually begin with a hyphen hyphen. Some variants of SQL might use hashes or something like that, but usually you're safe with just 2 hyphens. And so it'll also be typeset as a comment. You should be consistent on your table naming conventions, and we'll get into table design later on and exactly how to do that. One suggestion that I have that I didn't follow actually over here, but one suggestion that I have would be to use table names as upper camel casing and then column names as lower camel casing. I did follow that second convention here, publisher ID, lowercase, or lower camel case there. I didn't follow an upper camel case naming convention here on the actual table names, but we would suggest that you do that. Why? Because ultimately what you're going to do is you're going to be mapping your Java objects, we call them POJOs, plain old Java objects. You're going to be mapping those to tables. And wouldn't it be really nice and convenient, and you wouldn't have to think about it at all if they had the exact same names? Those columns had the exact same names as your field variables, right? Your member variables. And so if you follow that convention, then there's no guesswork at all, and you can go back and forth. Remember that we are online, so if you have any questions, go ahead and post to the YouTube live stream. Otherwise, in old school SQL, you'll see a lot of people use all caps. So for example, if you want to, and we will do this today, we're going to get into selection. So select, oops, whoa, there we go. There we go. Yeah. Select everything from game, or from game. There we go. Oh, oops, I need to use my database first. Sorry, use, there we go. And execute that, and then execute, select everything from game. Now, this is an old school way of doing this because remember, it goes back to the 1970s. In the 70s, they had green screen monitors. They didn't have, full color monitors like this. And so to offset an SQL syntax, an SQL keyword from everything else, they used a convention where they went uppercase on everything. Right? We don't live in the 70s anymore. We now have a nice, color monitors, and so we can have color syntax highlighting here, right? So save your pinky. Don't hold the shift key down the entire time that you're typing. Don't go over to the caps lock and turn it on just to do one word, turn it off to do the next word, on, off, right? Follow this more modern convention here of just using lowercase and everything. But otherwise, it is case insensitive, okay? White space generally does not matter, and so if you've got a very long query line, you can go ahead and go down to the next line, and I'll follow that as well. If you do, though, align things using proper indentation. Align things everything up so that it's nice, that it's at the same level. You can either use double quotes or single quotes to note strings, but just be consistent about it. If you're going to use double quotes up at the first 3 queries, then use double quotes throughout the entire script. Don't go back and forth between the 2. Every query ends with a semicolon. That looks very familiar, right? We call it C-style syntax because C did it, but this goes back even before C in the early 70s. I think that the actual language that started using semicolons to end stuff is maybe Fortran or COBOL or something. I forget. Doesn't really matter. A history lesson, and this is not a history course, right? History of programming course. I don't know if that would even be, an interesting course or not. So anyway, as we've already seen, you can go ahead and pull out data from a database, an existing database with existing tables and existing data that's already in those tables, using a select statement. Now, we've already used it implicitly up to this point, but to show you again, you can use the wildcard to pull every single column. So for example, I've already used my database here. So this star here is an asterisk, right? It's we call it the star operator. It's selecting everything. It's different from the wildcard that you're used to, say, in Java now. This is actually the more conventional wildcard. A wildcard will match anything. If you've ever done regular expressions or you've ever heard of regular expressions, The wildcard, that's sometimes it's called the clean star, K-L-E-E-N-E, named after a person. It's from regular expressions. It matches 0 or more instances. It matches anything, basically. Anyway, it's a wildcard, and what we're doing is we're selecting every single column of that table. The game ID, the name, and the publisher ID. If we take a look at the ER diagram on the game table, that's all 3 of those columns. Right? That's what the star means here. If you want to be a little bit more intentional about it, and you only want to say pull the titles of all the games, right? You can select, you can be more specific on which columns by specifying them. So instead of selecting everything, I will select the name and maybe, I don't know, publisher ID, right? From game. When I do that, I only get those 2 columns, name and publisher ID. Okay? If you want to, you can go ahead and just select just the name from game. And you will only get that, come on, it's going, there we go. And you'll only get that 1 column, okay? You can also use aliasing. You can use aliasing of table names, or of column names, and table names, but we'll do that later. So I'm going to go ahead and select the name from the game, but I'm going to select it as game title, right? From game. There we go. All I'm doing is renaming the column for the purposes of this query. It does not change the database, right? It's an alias. Just like, you know, a nom de plume or something like that, where you've got another name that you go by, a nickname or something. It is just for the purpose of this query. If I execute this, right, you'll see that the name has changed up here. It's kind of hard to see, but and I can't you know, zoom in on it. But it's a game title now, right? Obviously, you cannot put spaces in there. Right? So let me go ahead and try to do that, and I get that red X saying you can't do that. You can do something like this, though. There we go. Now that will work. Game space title. Ugly as hell. Don't do that, right? But I do mention it because this is syntax that you might see. What is that little symbol right there? That's not the single quote. It's a single quote, but it is slanted. Right. If you look on your keyboard, it's at the top left, right under the tilde. It is the backtick, right? And if you escape names within your SQL syntax using the backtick, you can go ahead and use special characters, right? You can go ahead and have all this stuff in your result, right? That's even uglier. Right? Don't bother. Just go ahead and go with no spaces and lower camel casing on everything. Okay? But you can also alias column names. All right, let me go ahead and get rid of this. And I'm going to go ahead and bring all of this over to the notes here so that you can see what it looks like, or that it'll be in your notes when it gets pushed over to GitHub. Right? So you can also, let's see, more fancy select statements. Right? So you can use aggregate functions first of all. You can use aggregate functions to compute results on the SQL server itself. So for example, what I want to know is how many games do I have? How many game titles do we have in our database? So if I just go ahead and say select everything from game, right, I can go ahead and try to count them up. Well, first of all, can I look at rely just on the game title here? If I went down here, would you say that there are 200 games in my database? No. Do not rely on the game title. Instead, you need an aggregate function. I want to know how many games are in here. And there is a function called count. Again, I'm not going to go with old school. I'm going to go ahead and go with the modern convention of using all lowercase here. And I'm going to count all of those values. Right? I come back with 22. There are 22 records in that table. Okay? Look at that column, though. Is that a real column? Count star, right? It's exactly the function that I just called, this aggregate function. Here is a good situation, a good use case for using those aliases as number of titles. There we go. And now I get a much more descriptive column name out of this, and I get a value of 22. Right? And it's got an arrow here, but there's just one result because you're asking for a number of them. All right. You can also be more intentional about your scope your select statements down using a where clause. You can specify more data, more fine-grained data. I said grained data queries using a where clause. So I'm not interested in all the games. I'm just interested in the games that say like one game based on the name. All right. So select everything from game where name is equal to GTA 2, let's say. There we go. And I'm going to get back one result there because it matched the result. What if I didn't have this? What if I said, I misspelled it, A2 here? Right? I'm going to get back, that's valid syntax. It's just I'm going to get back how many results? 0 results. So let me go ahead and restore that. And then you can use those in conjunction. Is there a game with GTA 2? You can go ahead and use select count of that from game where name is equal to GTA 2. There we go. And I get back 1. Right? And then you can use an alias on that as well. You can use this on any column. So select everything from publisher. Let's find out who the publishers are again here. How many games do I have by, say, LucasArts with publisher ID number 1? So I'll come back over here and I will select everything from game where publisher ID is equal to 1. And I get back actually 3 games here. Right? It looks like Lego Star Wars, TIE Fighter, and X-Wing versus TIE Fighter. Lego Star Wars was not by LucasArts though, was it? It was originally, but not anymore because LucasArts doesn't exist anymore, right? I don't know. Anyway, who cares? You can also combine things. So for example, I can select everything from game where publisher ID is equal to 1, or, and then again, lowercase that, or the name is equal to GTA 2. Right? And likewise, you can use and. You can use any combination that, oops, what's wrong? Publisher ID where, or name is equal to GTA, unknown, oh, I misspelled publisher. There we go. There. Now I'm getting back all 4 of those results. What if I change that to an and? Is GTA 2 published by LucasArts? Nope. So what should I expect back from this? No. Nothing, right? A 0 result set, right? An empty result set, okay? You can go ahead and combine these with a bunch of, you can put in parentheses, stuff like that, to make this really, really complex. Publisher ID is equal to 1, or actually greater than, let's go with greater than, say, 3, and publisher ID is less than 7. So, and then, and GTA is equal to 2. Or here, let's go with or. Right. So I'm going to get everybody, every game that's published by publisher ID 4, 5, and 6, but not 7 because it's strictly less than. And then or GTA 2 here. Right. I'm going to get all of those. So Legend of Zelda, Zelda 2, Tetris, and Super Mario Land, that is probably Nintendo. This is probably Rockstar Games, right? And the other one would be what? I don't know.
There is another one.
Is there? Nope, I guess not. There is another publisher in between, 4, 5, and 6, but I don't know. They must not have published any games in this database. Okay. You can use so you can use all of those tricks to winnow stuff down and get more data or less data. Other aggregate functions. So what's the oldest game? What is the oldest game? We're not there yet, but we can at least find the year that it was published. Right? Remember that we've got this ER diagram here. Over here in the availability table, I've got a publish year. I can find the oldest game, or at least the year of the oldest game, and I can find the newest game. So let's go ahead and do that. Select max of publish year from availability. Right, there we go. That will give me the newest one, 2011. And so I have not played any video games for the last 12 years, right? At least worthy enough to put it into this database, right? What about the oldest game? Min. There we go. 1985. Probably Super Mario Brothers or Zelda. Right? What if I want to determine, when was my prime gaming era, right? I can go ahead and go with an AVG, which stands for what do you think? Average. What is the average publish year? It looks like 2000, right? And it's .0000 because, of course, a bunch of integers divided by a number, et cetera, right? You can also do basic math, right? If you want to, for example, let's see. Not that it would make sense or that you would want to do this, but you could go ahead and select 10 times the minimum of publish year plus 3 from availability. Right? In other words, you can do basic math. Whatever the minimum publish year was, I'll multiply that by 10, and I'll add 3. And what will that give me? I think the year was 2011. Multiply that by 10, add 3, and you get whatever that is. Or the min was 1985. So 19,853. Right? There we go. And then, of course, that should need a name because this is just the expression that you have. So as some number, right? Some random number or whatever. So you can use basic math, and this is not the only. These are not the only ones. Max, min, average are pretty much 90% of what you would need. But otherwise, there are other functions built in. And if you go over to a different database system, they will have different functions available to you that might only be on that database system, right? SQL Server, Microsoft could say, we've got this brand new feature that to sell our database, we really want you to use it or whatever, right? And then it's not available in any other system. Right? I'm only showing you the basics. So you can get as fancy as you want with those, oops, not Java, but SQL. There we go. And you can get as fancy as you want. You can also have, you can do partial string matching. So for example, select everything from game where name is equal to GTA. We did this one already, or GTA 2. What if I want to get every game that begins with a capital G? Percent is yet another wildcard. So we've seen question mark as a wildcard in Java. We've seen star as a wildcard for the columns. You can now have use percent sign here for a wildcard within a string. This will match anything that begins with a capital G. It won't work because it is literally asking for a game title with G and a percentage sign in it. So we need to change this from an equals to a like, right? So it looks kind of like capital G and percent sign. Right? That will give me everything that begins with a capital G, okay? You can also, you can use as many of them as you want. How many begin with, or how many just contain a capital G? Any number of characters with at least one capital G followed by any number of characters. And that'll give me the same result here because those are the only ones. Any number of characters including 0, right? And each one of these doesn't start with any characters other than capital G. Well, what about, let's go ahead and try it with this. Oops, that's not what I wanted. Let's go ahead and go and try it with this. What about anything that begins with a lowercase g? Am I going to be getting anything back on this query? Nope. What does that tell you about these things? It is case-sensitive searching. Right? I'm crossing my fingers here because that's how I designed the database. You can design databases that are case-insensitive. I don't know why you would want to, but for many, many years that used to be the default on the CSE server. Thank God, at least 5 years ago, they changed that so it's no longer the default. Right? Everything is case-sensitive by default now. Okay? Well, what about anything that contains a, I don't know, a Z in it? I don't know, is there any game like that? Nope, even though there's Zelda there, right? Something a little bit more common, like a T, I'm probably just going to get almost every single game. Right? There we go. Anything that has a lowercase t in it. You can also match single characters. Let me get rid of this. You can match any single character using the underscore. So for example, I want to select any game from game where the name is like, it can begin with any single character here, but it has to be followed by an H, E, right? So the, or something like that. Oh, that's nothing. Okay, fine. A. Anything who, oh, nope. Okay, so, okay, sorry, I'm not using the all wildcards here. That's what I should be doing. Anything whose second character is a lowercase a, right? So one character, and you can have as many of them as you want, right? Anything who is 1, 2, 3, whose fourth character is a lowercase a, followed by any character after that. And I don't think that we're going to get, yep, there we go. Mega Man, Katamari Damacy, and Assassin's Creed. All of those have the fourth character as a lowercase a. So you can get as fancy as you want with this stuff as well. Lowercase, there we go. All right. Any questions so far? So I'm going to go ahead and bring these over and add them to the demonstration code that we just made. You can also use what's called an order by clause. Order by clause. Clauses, or clause, right? You can in general, I should say, I'll start out by saying, in general, the results you get back from a database are unordered. Right? Internally, a database has what's called an execution plan, and it goes out and gets the data that you asked for, and it does it in the most efficient way that it thinks is most efficient. Right? And that means maybe some pagination. So pagination, you see this on web pages all the time. When you've got infinite scroll, what that actually is automatic pagination. Where pagination refers to a page. So here's the first page. When you scroll down, load up the next page. There's the second page. It doesn't load, if it's like 500 pages of results, it doesn't load them all 500 at once because you're not going to look at necessarily all 500. You're just interested in the first or second one or something. And so pagination occurs. It breaks it up and gives you the first chunk of it. If you ask for more, it gives you another chunk. If you ask for more, it gives you another chunk. And so it could be that it's completely unordered. If you want to impose an ordering on it, you can using the order by clause. You can sort the results by any column using order by. Right? You can also, so in general, this is going to be the default is ascending order. So for example, let's just go ahead and select everything from availability. There we go. And I'm getting all of those years. But are they in any particular order? Nope. So let's order them. Order by publish year. By default, it's going to be in ascending order. 1985, 1987, ... 2011. That's the default. If you want to do it differently, right, select, I don't want to retype everything, so select everything in descending order, DESC, short for descending. Descending is not a keyword. It's not being highlighted here, and in fact, it's a syntax error. It's just desk, right? There we go. And now it's reversed. 2011 is at the top, and 1985 is at the bottom, right? Now, you can be explicit about it. This is equivalent to using ascending, which is ASC. Don't ask me why one's 4 letters, one's 3 letters, right? I would have said dec, no, des, no, dec, no. None of those look right, and that's why. I wouldn't have abbreviated it at all, but you're thinking back to the 1970s, right? If you could save on a couple of characters, you did it because you were paying by the character, literally. Right? You can have combinations, right? Or you can do strings. Let's do strings first. String order. Right? So, for example, select everything from game, order by name. And now I'm going to get everything in ascending order according to the title. Assassin's Creed is at the top now, A. All the way down at the bottom, Zelda is last. Now you can go ascending, descending on this. In general, it will be ASCII text values. So for example, if I had something in here with a lowercase letter, it might come at the end because all caps come at the beginning. Right? I believe, don't quote me on that. Again, it depends on the collation or the case sensitivity. Right? Let's see. If I want to group them by publisher, I could do something like this, and we'll talk about group by clauses here in a second, but I could go ahead and order first by publisher, then by name. So select everything from game, order by publisher ID, then by name. And you'll see here all the publishers, publisher ID 1, publisher ID 5, 6, they're all grouped together now. But within that grouping, what do I have? Legend of Zelda, L, Super Mario, S, and then T for Tetris. And you can go ahead and modify these using descending or ascending as you wish, right? Descending and then ascending. There we go. And that'll be a little bit different. Now that publisher 100, whoever they are, whoever did Assassin's Creed is there, and then we've got Hogwarts Legacy, 14, I don't know, 14, 13, 12. This is what another section gave me. Right? And then down at the bottom here, we've got LucasArts. I do know who they are. Right? And we've got Lego Star Wars, TIE Fighter, and then X-Wing in ascending order according to title. All that was needed was a comma here. First sort by this, then sort by that. Looks very much like an Excel table. If you have an Excel table and you hit that sort button, you have this nice graphical user interface that says, sort by this column, ascending or descending. Then by this column, ascending or descending. It's the same exact thing. Right? But we've been doing it since the 70s. Right? I was not alive in the 70s. Right? Okay. SQL. You can use the distinct keyword to get rid of duplicates. So let's go with publisher here. So select no. Yeah, okay, let's do this. Select publisher ID from game. So you see all of these duplicates here? That's because each one of those publishers published multiple games. Right? What if I only want distinct ones? I can put distinct in front of that, and I'm only going to get unique values at this point. Right? It's not unique, it's distinct. Right? Some variations might have unique, but in a different context. In fact, we will use unique in a different context later on. Right now, I just want distinct, and then of course you can use this in combination. All of these things that we've covered so far, you can use in combination with each other. So the distinct keyword can be used to eliminate duplicates. Right? You can use distinct to only get unique values. And I'll just put that at 1 in as an example. Right? You can use an in clause. An in clause. There we go. So sometimes you can treat a result as a set. So you're going, many of you are going through 235 right now. Tell me what a set is. And what's a set in Java? It's the exact same thing. A set is a collection of unordered, unique elements, right? For example, in 235, it would look like something like this, right? A is equal to, oops. We use the bracket notation here, A, B, C. There we go. Those of you coming from a Python background will really appreciate that. Why? What is that in Python, using the curly brackets without a key value pairing? It's a set, right? Exactly. It's unique elements, it's unordered. Even though sometimes we often will write it A, B, C, it's unordered, right? So hopefully you've seen this symbol, X in A. There we go. What does that symbol mean? X is an element of A, and we read it as X in A. In fact, that's exactly what the LaTeX is. Let me show you what the LaTeX I'm drawing here is. Right? It's that, is that a backslash or a forward slash? Backslash. Backslash in A. Right? there's your sets. How does that work with databases? Let's see. I could do something like this. I could say, select everything from game where game ID is equal to 1, or game ID is equal to 5, or game ID is equal to 9. And I'll get back those 3 games. Awesome games, all of them. Right? Or I could go ahead and shorten that using the in clause. What I could say is select everything from game where game ID is not equal to this or that or that or that, but it is in this set, 1, 2, or 1, 5, and 9. There we go. Now, unfortunately, we're using that tuple notation, right? I'm not sure what would happen in Python if you conflated a tuple and a set. Any ideas? You could probably get away with a lot of stuff, but not everything, right? So this is not really a set. We don't use the square bracket notation here. We're using this parenthesis notation here. And so that'll give me back the exact same 3 games. Why would you want to use this? This allows you to use a subquery to pull more data. So for example, I want to know what's the publisher ID of LucasArts. Select publisher ID from publisher where name is equal to LucasArts. There we go. 1. Right? Well, if I could go and go back and hard code that and give me every game that is published by that publisher, I could say select everything from game where publisher ID is equal to 1. That would certainly work, but that requires me to do 2 things. And if I'm doing this interactively, that's fine, but if this is programmatically, if I'm writing a program to do this, and I want to automate stuff, I don't want to have to go back and execute this. Okay, 1, now go ahead and type that and execute that. So what I'll do is I'll combine both of these things into one thing. Right? So select everything from game where publisher ID is in this subquery right here. Now again, it's a long line, so let me go ahead and break that up into 2 lines and then indent a little bit. Select everything from game where publisher ID is in this set. But instead of hard coding that set to 159, what I've done is I've made another query. That query will go out and get the publisher ID for anybody whose name is LucasArts. And it will end up replacing it with something that looks like that. And you can get as fancy as you want, right? Where, I don't know, L? Are there any other publishers that begin with an L? Let's find out. Apparently not, but you can do something like that. Or here, it is equal to LucasArts, or name is equal to Nintendo. There we go. And I'm going to get all the Nintendo games, and I'm going to get all the LucasArts games. Of course, you could put in, replace this, or that with yet another nested query. Let's go ahead and do that and just show you what it looks like. Come on. Where name in, and then I will have a comma separated value, and then a comma separated list here, and have that. There we go. Indentation, indent, indent. I'll do it like this. There we go. That looks nice. There. Same exact thing. All right. No questions so far? Otherwise, this is, you can get really, really fancy with this stuff. In fact, you can become a DBA. What is a DBA? Somebody that just doesn't write any front-end code, doesn't write any back-end code, just lives in the database day in and day out. They are database admins or administrators, right? And they're writing this stuff all the time to run reports, or they'll write a query because somebody wants a report. I'll go ahead and write a query, put that into a function, and then we can run that over and over again for as many times as you want. Right? Otherwise, we're going to get into some even fancier stuff here now. Data projections. Right? So what is a projection? Think about a cube, a three-dimensional cube. Now, if I were to draw a three-dimensional cube up here on the whiteboard, would it be a three-dimensional cube anymore? Is that whiteboard 3 dimensions? Nope, it's 2 dimensions. So if I were to draw it up on the board, of course I would draw it as maybe a square, depending on your perspective. If you were looking right at it, it would end up being a square. If you were looking at it a little bit offset, then you would have that classic, wow, you can draw in 3D kind of thing from grade school, right? And then you can add shadows to it, and now you're an artist, right? That's called a projection. When you're taking something of a higher order dimension and you are projecting it down onto a lower dimension. You take this three-dimensional cube, you project it down, and it becomes a square. What happens if you take that two-dimensional square and you project it down onto one dimension? You can't do that. What happens? The square becomes a line. What happens when you project that down onto a zero-dimensional space? The line becomes a point. Let's go up one dimension to the fourth dimension. Right? What does a cube look like in a fourth dimension? You all know it because of those Marvel movies. Tesseract, exactly. That's what a tesseract. Or a hypercube, or there it is. There's what a tesseract is. Right? That is a fourth dimensional cube projected down onto our three-dimensional space, and that is our perception of it. Right? It's just, it's not real. It's just a mathematical description of higher dimensional things being projected down onto lower dimensional things. Sometimes that's called a hypercube. You can do the same thing with data. So for example, I want to do the following. Let me go ahead and get rid of all this. All right. I want to find out how many games each publisher has published. So remember that LucasArts, I think, published 3 games. Nintendo published 5 games from the results that we've been looking at so far. Right? Well, I could go ahead and run this and look at and resort this with respect to publisher ID and say, oh, LucasArts is 1, so therefore I've got 3. Nintendo looks to be 5, and so I've got 1, 2, 3, 4, 5 there. But I want to do that as a query. I want the database to do my work for me. So what I need to do is I need to project the data down to 2 dimensions, right? I'm going to take it from publisher ID, number of game. Here, wait. Let's go ahead and look at the data again here, and let's look at. Come on, run. Question online. Okay, it's just spam. Sorry. Anyway, game ID, name, and publisher. That's 3 dimensions right there. What I want to do is I want to project that down onto 2 dimensions with the publisher ID and then the number of games they've published. There we go. How do I do that? To understand this, what I want to do is I want to show you another example, and then we'll build on that example. I'm going to be using what's called a group by clause, along with maybe an aggregate function. Okay? So let's just take a look at this example right here. I've got a 3-dimensional piece of data. There are 3 pieces of data with each one of these records. There's the title of a book, there's the author, which I've just crunched down into one column here, and then there's the number of copies of that book in my library. So for example, I have 10 copies of Norman Mailer's Naked and the Dead. I've got 1 copy of Douglas Adams' Long Dark Tea Time of the Soul, right? Okay. So what I want to do is I want to know how many total copies of each author's books do I have. For example, Norman Mailer, I've got actually 2 books, The Naked and the Dead and The Barbary Shore by Norman Mailer. One of them I've got 10 copies, the other one I've got 3 copies. I want to get back 13, the total number of copies of all Norman Mailer books in my library. Likewise with Douglas Adams, I've got 3 Douglas Adams books, 4, 2, and 1. That's 7 copies of all Douglas Adams books. And then finally, Orson Scott Card here, I've got 7 copies of Ender's Game for some reason. Okay. What I'm going to do is I'm going to sort them first. Right? Now, I'm not actually going to sort them. The database is going to do this for me. It's not actually sorting them anyway. It's grouping them, right? Because Norman Mailer here comes before Douglas Adams. There's no order. What it's doing is it's putting all Norman Mailer first, then all Douglas Adams second, then all Orson Scott Card third. It's grouping them by author. That's where we get this group by clause here. And then I'm going to project it down. I'm going to take those 3 dimensions and I'm going to project it down onto 2 dimensions, the whiteboard here. Crushing one of those dimensions. When you go from a square down to 1 dimension, one of those dimensions is lost and you've crushed it down. Right? Just like taking a cube, you've crushed it down onto a 2 space. You've lost something. When I do that, however, I'm able to aggregate and collect all of these numbers together as a sum. Okay? The way that this is done is using this select author, sum of all number of copies as total copies from book, group by author. That's the basic. That's the basic syntax. Let's go ahead and do that over here in game. Right? So once again, let's go ahead and remind ourselves about the data that we have here. Right? I want to first group them by their publisher ID, so that all LucasArts games are together, all Nintendo games are together, all, whatever, Delphine software games are all together. So select everything from game, group by, and it's 2 words here, it's not 1 word, publisher ID. Let me execute that and show you what's happened here. Publisher ID 1, 5, 6, 8, 10, etc., etc. It's projected it down already for me, but it hasn't given me what I want yet. Because I'm still selecting everything. I'm not crushing that 1 dimension. So what I want is the publisher ID, right? And then the, well, here, I'll do it like this. I'm only going to get those back. That's not what I want. I want a count of the number of games by this publisher. Right? Now, that's not real syntax. That's just me saying what I want. How do I get that? I'm going to take a count of the publisher IDs. Right? So when 1 appears 3 times, 1, 2, 3, there's your count. 5 appears 5 times, 1, 2, 3, 4, 5, there's your count. Right? And I'm going to select the publisher ID and the resulting count. Remember that 1 was LucasArts and there were 3 games by it, TIE Fighter, X-Wing versus TIE Fighter, and Lego Star Wars, right? 3. There were 5 Nintendo games there, 5 and 5. What are the rest of these? I don't know. Do I have enough information to determine that? Not yet. So think about that for a second. What if I did this instead? Just count everything. Am I going to get, oh, okay, I'm going to get everything. Count, how do I want to screw this up? I can't think of how to screw something up intentionally off the top of my head. Oh well, that's fine. We'll go ahead and just count publisher ID. We'll screw it up some way another time here. All right, from game, group by publisher ID. Right? I'll break that up into 2 lines there. I do want to alias this, right? Because publisher ID and count star, is that a real column? No. It's an aggregated column. It's a created column for the purposes of this query. It's not stored anywhere in the database. It's stored in the results that I pull out of the database. So let me give that a name using an alias. What should I call this? Number of titles. There we go. There. Number of titles for the first one is 3. Number of titles for the second one is 5. I really want to know who these people are, or who these companies are, right? I know that 1 is LucasArts and I know that 5 is Nintendo, but what about the rest of them, right? And in fact, we have more publishers than just these. What about publisher 2, 3, 4, and 5? They've published how many games implicitly here? 0, right? How do I get them in my query so that I have an explicit piece of data that says this software company has published no games in this database so far? To do that, I'm going to have to bring 2 different tables together, the publisher table and the game table, because the publisher's name is in a completely different table over here, all right? And the game table over here only has the name of the game and the publisher ID. So what I'm going to ultimately do is I'm going to take these 2 tables and I'm going to join them back together. That's called a join query, right? Or a join clause, whatever, right? Whatever you want to call it, right? It's a join. I'm going to take that table and join it to that table, but I don't just want it to join, just willy-nilly. If I did that, let me show you what it's going to look like. Select everything from game, G, join publisher, this is a preview of what we're going to work on Monday, join publisher P. Right? By the way, these are aliases. Well, I don't need the aliases. Now, forget that I did that. Remember that we'll do that on Monday. There we go. I've just joined them, you know, without any regard to the data integrity here at all. GTA 4, was it published by LucasArts and Sony Entertainment and Square Enix and Sega and Nintendo? Nope. This goes back to your sets in 235. So let me go ahead and draw you a set here. A is equal to A, B, and C. There we go. All right. There's a set, say, from 235, discrete mathematics. How many people are not taking 235 right now? Okay, a couple of you? All right. This is okay. You've probably seen this before. You've implicitly used this in your entire life, right? This is called a Cartesian product. A times A. Now, this is not a number, right? This is a set, right? And what I'm doing is I'm taking that set times that set, meaning that I'm going to have a bunch of pairs. Right? A pairs with itself. A pairs with B. A also pairs with C. What else is in this set? This Cartesian, we call this the Cartesian product or the cross product. We call it the cross product. Why? Well, there's a cross right there, times. We call it the Cartesian product. Why? Think about Cartesian. Where have you heard the Cartesian coordinates before? X and Y. What are X and Y? The real numbers. X maps to Y, right? You have a pairing, X and Y. This is why we draw points in the Cartesian plane with parentheses, X comma Y. This is exactly what we're doing here. This is a relation on a set. B, A. What else? B pairs with B. B also pairs with C. C also pairs with A. Right? It is ordered. These are pairs. These are orders. C pairs with B. And finally, C pairs with C. I started out with a set of size 3, and I ended up by taking the Cartesian product, the cross join with respect to databases, and I ended up with how many things? Each one of these over here pairs with each one of these over here. So 9, right? 3 times 3. How many results do you think I have here? How many publishers did we have? Did we ever count that? Select count of everything from publisher. Execute that. I have 17. So let me change this to count star 374. What are the relationships between those two numbers? Yeah. Say what? 17 times 17 is 374. In other words, I was doing a full join here. That's not what you want, right? Because, I mean, it's weird. Those games were not published by those publishers. What I need to do is I need another piece. I need to say that thing belongs to that thing, but only if their publisher IDs match, right? Once I do that with a where clause or using a join, then I get all the data that I want. I get all the publishers and their games, all that data crunched together like I expect. And that's where we'll pick it up on Monday.